Okay, so today in today's experiment, we're going to be doing the electron configuration laboratory. So before everything begins, make sure you put on your portable laboratory coat, you put on your goggles, and I've taken the liberty of preparing all of the equipment that we are going to use today. So we have solutions of sodium chloride, potassium chloride, lithium chloride, and calcium chloride. Now, what we're doing in today's laboratory is that we are going to observe the flame test for each of these four solutions when we place a sample containing these metal ions, or anions for that matter, into a flame. The flame will excite the electrons in our metal. They will promote to a higher energy level. And when the electrons relax down to the ground state, light will be released. And the exact color of light depends on the relative energy of the energy levels for that element and the relative energy of the electron transition. And based on the energy of the electron transition, a photon with a discrete energy is released, and in turn, we see a different wavelength or color of light. So we'll be able to see a distinct relationship between an element's identity and the wavelength or color of light released during emission from a flame test. Now, with that established, we're going to be using our sternal burner. Now, one thing that's really important as we're dealing with a flame, the gloves that are provided in your lab box kit are not heat resistant. So you want to make sure you have insulating materials available. So we have our sternal burner set up and we have our solutions. Additionally, we have our pre-prepared inoculating loops. Here we go. So here's our pre-prepared inoculating loop. Notice how at the other end we have some insulating clay just to minimize heat transfer. And we're going to dip our inoculating loop into each of these packaged solutions, and we're going to observe the color of the flame after heating our sample. Make sure to not cross-contaminate the loops. So we have a total of 4 loops for each solution. So we'll be recording our observations as we expose each of these samples, each of these solutions of metal ions to the flame test. Now, to handle our sternal burner, just like last time, I have it on insulating surface and I have extinguishing materials prepared. The area is free of any flammable materials and the surface itself is non-flammable. Okay, so now we're going to uncap our sternal burner. And you're going to keep the cap on the side. So you're going to keep the cap on the side. Remember, to extinguish your sternal burner, you're going to place the cap back on to smother the flame. Once you light your sternal burner, do not, and I repeat, do not touch the sternal burner with your bare hands. It will be hot and it will burn you. Additionally, avoid moving above the flame as the flame may not be entirely visible. So now what we're going to do is we're going to light the sternal burner. So once you've verified the area is clear, we're going to light the sternal burner. And then I'm just going to quickly douse my match with water. Okay, so my sternal burner is lit. While the sternal burner is lit, you have to keep constant attention on it. And the wick should be lighting. We see a somewhat, well, it's a mix between a luminous and non-luminous portion. So now that our sternal burner is all set up and ready to go, we're going to start by testing our solutions. So first things first, we're going to start off with the calcium chloride. So we're starting off with the calcium chloride solution. So I'm going to take my loop, and because these solutions have been specially made and designated only for this experiment, I'm going to take my loop and put it in. So I'm going to dip my loop into the mixture, into the solution. And you want to make sure that you've collected so you should have collected liquid in your loop, and then you're going to place the loop into the flame from the side. Okay, we didn't see anything there. Wait for your loop to cool down and then repeat this process. Okay, so this time I have it pretty good. So if you notice, you can see that I have a bulb of collected liquid in my loop. So now what I'm going to do is I'm going to insert my loop in from the side. I'm going to see what flame color I observe. It's sometimes very tricky to observe the flame color. Try to notice and look for any distinct changes in flame color. No, nothing yet. This may take a few tries. You should see a very distinct, almost red color. Make sure you aren't just noticing the flame interacting with your metal. So you'll want to try to sneak it in on the side. It's tricky. You want to aim for the edge of the cone of the flame. Let's try. We'll return back to calcium. Let's try a few of the more distinct ones. Potassium's hard. Let's look at sodium. So let's look at sodium. So we're looking at sodium chloride. We were looking at potassium previously. Now we're looking at sodium. I'm just trying to get a good response from it. So let's try coming in from the side. Okay, let's try again. Sodium produces a very distinct yellow color. But it's pretty hard to do with this flame strength. Is everyone noticing a unique color? Is everyone noticing that yellow color? Flame tests are a little bit finicky in terms of you want to aim for the hottest part of the flame, which is the tip of the inner cone. Let's try potassium, since although it's hard to see, it's very different than any of the other colors. This is one where you really have to just sort of try them multiple times just to check. We were looking at sodium chloride. Now let's look at potassium chloride and see if we can get a distinct color. So we have potassium chloride. Oh, do you see it? Do you see that color? This one's good to see. This one you can really tell. Okay. Okay, I want you to watch this really closely. This is potassium chloride. What color do you see? Does everyone notice that side color being added to the flame? Let's try one more time. Does everyone see that pink purple color? Does everyone see that pink color appear? How does it look to everyone? Let's, I'll view it from the camera perspective to see if you can see it. Does everyone see that pink purple color? That pink purple overtone? What does everyone think when you're testing your samples using your own flame? If you bring it from the side, does everyone notice how that orange color has a bit of like pink and purple to it? Watch, here's just a comparison. So if you compare, like if we just dip the flame in, it's sort of red. But if we dip our sample in, does everyone notice that pink?
Oh yeah, it has like a hint of it.
Yep, exactly right. And that's what you're picking up on for potassium. Does everyone see how you get this pink? I'll keep doing it just so that way I find it fun as well. Now, the one thing that you can immediately see is that when you just naturally dip your testing in, you don't see that pink overtone. That pink overtone is coming from our sample. That pink purple overtone, does everyone see that? let me reduce the light in this room a little bit, and let's see if that's easier for everyone to see. I'm going to reduce the light a little bit, and then let's check. So I made it a little bit darker in this room. So let's see if we're able to pick up on this. So this is potassium one more time, this time when it's a little bit darker. Let's try it one more time. Does everyone see that pink overtone?
It's like a cotton candy color.
Yep. A pink purple overtone. If the solution's concentrated, you'd see this super bright purple. Okay, let's look at lithium. Let's look at lithium. And then I'll show you a bonus one if it's in your lab box, as there are a few colors that are pretty bright. Does everyone see that for lithium? Can everyone see that? This one's distinct. Does everyone see that beautiful red color? That is the flame test result for lithium and also strontium, which is used in road flares. Okay, so now it's much easier for us to see. So let's do one more, just so that way we can. There we go. Perfect. So that was lithium. Let's go back and let's review and let's rediscuss and reanalyze sodium chloride. Let's reanalyze sodium, and we're looking for a bright yellow flame. Sodium is bright yellow, like banana yellow almost, if it's really concentrated. So let's put this in the flame. It's hard to tell because the flame is orange, but let's do it a few more times. Sodium is sort of yellow orange, so it's hard to tell.
It looks bright yellow on camera.
That's good. That's good. That's the color you should be seeing. And it should be different than if you just put it so. It's hard to pick up flame color for some of these colors, but as we saw, sodium, it's a sort of yellow-orange color. Let's do one more look at calcium. So let's look at calcium chloride one more time. Let's see if we observe a distinct color for calcium chloride. Does everyone notice that color change for calcium? Does everyone notice that color change? What color do you see? Does everyone notice that orange color for calcium?
Yeah, it starts off as orange and then goes bright yellow, kind of.
Yeah, the bright yellow is not the genuine color, but that orange is the genuine emission for calcium. Okay, now I'm going to show you a bonus one. So looking at the solutions that we have. Let's see, do we have copper? I'm going to look and see if we have a copper solution. Well, we don't have a copper. We don't have a copper solution. Let me pause for a moment and I'm going to show you what copper looks like. This one's really cool. You don't have this one in your lab box, but I'm going to show you this example just to show you what copper's emission looks like. So I'm just going to pause for a second. For the last one, I'm going to show you a bonus example, and let's try to see, what does copper look like? What does copper look like? Let's try one more time. You could almost see it. Does everyone see that small hint of green color? It's a little hard to see. It's really subtle for this one because I didn't make a very concentrated solution for copper.
You can see it, it's subtle.
Okay, perfect. So that's, as a bonus, the emission of copper. So a lot of these elements are used as additives in fireworks in order to create unique colors. So checking at this experiment, we have completed our analysis of all of our samples. So now we're ready to extinguish our sternal burner. So in order to extinguish our sternal burner and to complete the cleanup, just as a reminder, you're going to suppress the flame by very quickly covering the flame, using your forceps to place the cap over the flame. Now you're going to allow the flame to be smothered and you're going to let your sample cool to room temperature, and we'll clean up the remainder of our setup. So with that, we have all the data we need to complete today's experiment. We're going to allow our sternal burner to completely cool to room temperature, and then we'll clean up, and we have all the data we need for today's laboratory.